Hi, everyone. Thank you so much for joining us for this really incredible session we have with the authors of Reliable Machine Learning. My name is Aparna. I'll be your host for this session, but I will hand it over to our incredible panelists to introduce themselves. Niall, do you want to kick us off?
Sure thing. I am currently CEO of a teeny tiny startup in the SRE/ML space called Stanza Systems. I am also here on foot of a large number of years in Amazon, Google, and Microsoft, and I'm also a co-author, instigator of the Site Reliability Engineering book, SRE book, if you've come across that.
Super exciting. We will definitely be diving into the parallels between SRE and ML. Cathy, do you mind introducing yourself?
Sure. My name is Cathy Chen. I am an executive coach and also work at Google as a program manager and have been in SRE for the probably 6 out of the 18 years that I've worked at Google, and most of the time working with Todd. I blame Todd for everything, including my working on this book. Todd, how about you go? You're on mute.
I was going to ask if Niall and Cathy wrote any other book. Niall mentioned the SRE book. Was there some specific book either of you was involved in writing that has something to do with this panel? Anyone? Anyone?
Well, we already mentioned the Reliable ML book that we're all the authors of. Yes.
All right, good. Yeah, so I'm Todd. I currently work in the office of the CFO at Alphabet. I don't know what I do, but it has something to do with figuring out how and how much money on what Google should spend and Alphabet should spend on ML investment stuff. Prior to that, I was the founder of ML SRE and was on, I don't know, 8 or 10 or 12 different SRE teams over the course of 14 years at Google. I'm based in Pittsburgh.
Awesome. Well, thank you all so much for being a part of this panel. For everyone listening into this session, first, I just wanted to maybe ask you all to introduce the book. I mean, your book has been, received really positively by the ML community and the MLOps community. I've seen people quote your book, share pieces of it online. What inspired you to write, maybe give a little bit of what inspired you all to get together and write Reliable Machine Learning?
Yeah, maybe I can start off. Like, I think for me, so I had been doing reliability engineering work on ML systems at Google since about 2009. And one of the things that struck me about ML engineering as it was discussed in public was that there was just a lot of gatekeeping. There was a lot of like, you need to have a PhD, you need to build models. And I think those are great skills. Like there's a whole set of like very sophisticated mathematical analysis, very sophisticated algorithmic analysis that is super important. It's at the core of what we do. But nobody says to sort of systems engineers, like, if you don't know how to build chips, you're not allowed to like work on a web server. So I was like, well, why is this? And like, we thought, so I talked to Niall for a bit about it because he has experience writing books, and he had also worked on one of the ML systems with me for a time when he was at Google. And we just came to the conclusion, we're like, it's not necessary. We should really open up the space above the algorithmic model development stuff. And that was where the connection with Cathy came as well, because as soon as we started thinking about that, we looked at the broader world and saw there's really a lot of organizational questions. And Cathy didn't mention it, but she has a background in organizational psychology. And we're like, hey, like, if you are Joe Blow, Jane Blow, senior manager at a company that wants to introduce ML, but you don't know a lot of ML and neither do any of your staff, you do what? Like, what now what? And we're like, oh, we should do that too. And so combined with our other 2 co-authors, we really tried to attack, the whole space above the algorithmic space.
And I'd say the first half of the book is about machine learning. So if somebody is coming from an SRE background or even a business background, they need to know enough about machine learning to be able to be a little dangerous, but to know what's going on, then that's the first half of the book. And then the second half of the book really talks a lot more about what are the elements about reliability? What do you need to be thinking about on your teams? A whole bunch of really, really, really great case studies and interesting stories on like, don't do this, try not to do that. And we try to address a lot of different audiences, not just the people who are, super skilled in machine learning already.
100%. I think what you guys did was incredible, because you're totally right. The people who sometimes end up being data scientists come from PhDs in machine learning or PhDs in these amazing fields. But there's been, I mean, the last 3 to 4 years has been incredible for ML ops and bringing these types of machine learning models actually into production. And that doesn't just involve the science sometimes. It involves so much more to get it into the real world. And maybe that, there's kind of a theme of questions I have for you all around, you were all very, very involved in, kind of SRE, deploying large scale infrastructure. What are the biggest challenges when you think about that practitioner space, when it comes to deploying ML systems versus, other software systems? And Niall, maybe you can take this one, but what are any big differences or similarities that you see?
Yep. So I suppose if we leave to one side everything about like model construction and figuring out the actual problem space, all of which are full-time jobs in and of themselves, and people specialize for decades and so on and so forth. But if we think about how to distinguish these spaces or how they could talk to each other, I suppose the first thing to say is that running a model in production and making sure that models make their way to production successfully, and figuring out that they are running, in fact, successfully, and defining what successfully means, and a whole bunch of other questions, are things which are different in the ML case than they are in kind of non-ML cases. So like if you have a standard web server, like I'll just go for that classic example. If you have a standard web server and it's some kind of e-commerce shop or whatever, whenever you post a purchase or get a product page or something like that, you expect it to return the same result or do the same thing each time. And that's not necessarily the case with ML systems. And in fact, almost by definition, their answers are going to change if you are training and inferring over a regularly rotated set of data. So that's one key difference. The second difference, I think, from kind of flows from that, which is to say that there are immense computational and storage and network demands to the act of constructing models, building them regularly, serving them, et cetera, which are not necessarily there in other kind of cases. Not to say that there's no other applications which are computationally demanding in the world. Of course there are, but like that particular amount of demand and the way that it is spaced out, training and inference and so on, those are kind of pretty characteristic differences.
So maybe like summarizing that, it's very expensive, it's very complicated, and we never know when it works. Right? And I think everything Niall said is right, but wow, like for a company to decide, should I spend money on this? Or for a team to decide, is the model working? Like, to Niall's point, your model can be working and then the world can change tomorrow. So you didn't change anything, but now people aren't as interested in the same thing they were yesterday. And now now your model's terrible, but it was never perfect and it's not broken. It's just less good, and I think that for monitoring and for management is just a huge challenge.
Can you share, because I think, people who are in, who deploy models and serve it, they feel it. But for some of the others in the audience, I mean, can you guys share some examples of when does reliable, when is machine learning not reliable? Like, what is an example of that? And why is that reliability important? I get people who ask me all the time, really, models can break? Models might not work in the real world? And, I think, I've debated, well, is it because the person who builds the model might not always be the person who deploys it into the real world? In some organizations, that might be the case. But yeah, I don't know, Todd, maybe you could help us, maybe help the audience understand what does it mean for machine learning to not, what does it look like for it to not be reliable, and why is that important?
Yeah, I think in the reliable machine learning book, we have a whole chapter on sort of case studies and a chapter on incident management. But the other place people might want to look is Daniel Papazian and I wrote a paper of 10 years of failures on one particular ML system at Google. And it's just real stuff that breaks. And I think what's fascinating to me is like, we all have highfalutin jobs and they're real fancy and we feel important. But when you look at how these things break, it's often, there were 2 data files, but I only copied over one of them. And it's embarrassing. Like it's not interesting. It's not. So when Daniel and I looked at the real causes of failures, the plurality of them were boring systems related stuff. I scheduled the thing to pre-process the data, but it didn't finish before I started the thing that needed the pre-processed data. And that's not interesting. That's not special. It's not fancy. It's just you did it wrong. You didn't check. And then you trained on garbage and you didn't notice. And I think going back to something Niall said, the problem is that you can do all that stuff and still have a model that's kind of okay. It's just not as good as it would have been. And that's what's problematic, is that detecting that stuff is hard because, like, if again, to Niall's example, if you have a web server and it returns 500s, it's returning errors, then you know it's broken. But if you have a machine learning model that's not, like in our example of the yarn store, if people aren't buying quite as much of the yarn you wish they were buying, is that because they don't want it or because your recommendation system is bad? I don't know, hard to say, right? And so anyway, yeah, I think that most of the failures I have seen over the years are systems related failures associated with, as you say, Aparna, like the distributed nature of this stuff. So system 1 is interacting with systems 2, 3, and 4. Person training one piece is not the person making the lookup table for the other piece. And sometimes we have fancy names for this stuff, like training serving skew. That just means I screwed up the definitions of my features so that they're different in place A and place B. Like it's got a specific name, but you're like, it's not interesting. It's just like I bucketed age differently, or I said this field was zip code, but I'm treating it as income. People do stuff like that all the time. Zip code could be your income. That might be good. That might be bad. It depends on your zip code, I guess. Like on the East Coast, it's not good because all those zip codes start with 0. But maybe on the
Bad
West
for New York, I'm thinking. Possibly quite good for Mountain View.
Yeah.
Related, I suppose a related observation is in the successor to the SRE book, the SRE workbook 2018, there was some old work suggesting that 70% of outages flow from configuration or binary changes of some kind. Like the system's basically stable, you change something, it mucks up fine. But when you step back and think, oh, actually an ML system is basically changing all of the time, like possibly every second, that might give you a feeling for how reliability might matter in these circumstances.
Got it. Okay, that was super. I feel like in the space, and I still walked away learning something from that answer, Todd. So Niall, so thank you. That's a great way of putting it. So okay, so how can folks, maybe we can jump from, all right, this is clearly what motivated you all to get together, write this book. You felt the pain yourself. You've seen it in the SRE world. You're seeing it in the ML world. What are some of the best practices that you all learned over the years and how to achieve ML reliability? I mean, there's the component, maybe we could start in the ML lifecycle. What do you do before you launch the model? And then what do you do, how do you approach that testing and validation phase to make sure that before the model's, even deployed, it's reliable and accurate?
Well, maybe we can take a step back and hear from Cathy about, because I think like one of the things that's before you even do that is, do you have an organizational framework that's capable of hiring the right people and making reasonable decisions about what models are you training and how are you because like what we found is we were, Cathy and I were working through some of the stuff in the org chapters and the incident management chapter. There's some real questions there that are really like organizational questions, profit and loss questions, service to customers questions, politics questions. When you're like, well, should I roll back the model? Should I leave the model in place? That's bad for some customers and not bad for, am I at legal risk? And all of those have a little bit of an organizational context. So Cathy, maybe like we can start with some thoughts there.
Sure. I mean, I think one thing we talk about a bit in the book is like whether or not you centralize your model team and you centralize your infrastructure team or not, or do you just keep it all dispersed or distributed? And so if you centralize things, then you have some advantages, right? Everybody knows what changes are happening in the models. You can kind of test all at the same time. You can decide how you're going to deploy. However, it might have the disadvantage of those model builders get farther and farther away from the business and don't really understand, what their models are supposed to be doing. And so then if you decentralize and have your model builders in each business unit or kind of far apart, then that's where conflicts can come up. And, in the book, we have a couple of these examples of like, if one model builder team starts doing something and then another team does something else, you could actually end up deploying something that is causing privacy issues or something like that. So I think especially, in this day and age when, either you're a small company, you're trying to think about how to do this, or you're a large company trying to get into this space, what do you centralize and what do you not centralize is really, is a question for the business people, but also for the people who are working on, not only the models, but the infrastructure as well.
That's so true. And it probably changes as the organization's growing too.
Yeah.
So how, maybe what would you all recommend for a group, let's say you're a smaller startup, should the individual data scientist or the model owner own that testing and validation? And then as the company grows bigger, or if it's a larger company, do they start to standardize some of those testing and validation practices? Any ideas like, and this is, I feel like the space is changing week by week right now. So any recommendations for how companies should think about best practices and standardizing this?
Yeah, so I think, Cathy may have some thoughts, and Niall spends more time talking to real companies now too, so you might have some more recent data. But I think like going back to something Cathy said, like the context for that decision is, what are you using ML for? Like some of these conversations sound really boring and basic. You're like, oh, well, that's kind of a simple question. But we find a lot of I find even a lot of teams inside of Google and in other places I talk are like, we're going to use ML. I'm like, cool, why? Like, why is that the right choice for you? Why is how important is it for you? What value do you expect to get out of it? And what I've seen when I talk to people that way is about half of the people are really we don't want to be left behind, so we need to use ML. We don't know what for yet. The decision is machine learning. The next step is we'll make the decision what to do with it next. And that's just such a strange place to be. Whereas if you take a step back and you say hey, there are some problems we have that we're pretty sure can be solved with machine learning. We can have an intentional effort to do that in some investment. Then you can go, Aparna, to answer your question, which is okay, how are we going to do that? Are we going to do a series of small experiments? Are we going to have one data science team start there? But I think, to Niall's point, this stuff can be really quite expensive. It doesn't have to be, crushingly expensive, but in general, if you're training your own models on data and you're updating those models and you're maintaining production inference, those things are going to add up. So you better be sure you're going to get something out of it. And then once you know what you expect to get out of it and what you're paying for that, you can sort of look at the sizing and say hey, if this is really a tacked on experiment, it's okay to have that team over there validate it as long as we keep an eye on it, because we don't want to damage our organization, but it's not consequential. But often we see those go from that to, this is the core of our business. Nothing works that well if that's not working. Well, then you have to actually really rethink, development, validation, and all kinds of things before validation, provenance of data. I see people being sloppy with data all the time. I have 3 data sets. I'm like, cool, where'd you get those? What version is that? Where did you store them? is that model over there that she's training on exactly the same data set as you're training? Do you have a feature store? Do you have data provenance that shows that you have the legal right to use these data in this way? And people are like, no, like there were some files and I copied them over here. You're like, that's probably not good enough. So I don't know, Niall or Cathy, if you have thoughts on like in the real world, how that plays out with real companies.
Well, I have a slightly different position at the moment, shall we say, because I'm not talking about teams, I'm talking about individuals, and all of my company could fit in this room right now, and probably room for like a table tennis table or a pool table or something. So when you say we'll have the team take care of this, I'm like, the team is maybe 1 people or 1.5 people. Because that's one of the other interesting things about ML. In the book, we do say that it has 2 characteristics which are interesting organizationally. The first one is it is a through line in kind of everything, because it adheres, accrues, is kind of tied to data in various ways, and data is everywhere in your organization. So in a small startup, that kind of plays out, in my opinion, at least in the startup I'm in. I don't make huge claims about other startups, but it plays out that kind of everyone is touching it in some way or other. And maybe there are people who are specialized in building models because, yes, okay, some of that stuff is quite specialized, but everything else about even the business purpose for the model, how much we should invest in that, those kinds of questions are like everyone's kind of involved. And like we are living a lot on AWS credits right now, not looking forward to them running out. That's going to be a interesting moment for us. But the idea that, okay, let's be intentional about what specifically this solves, even if the thing that you're doing is super experimental and you're not even sure that anyone else has done it in the world ever. Like there's a certain amount of purely exploratory stuff you have to do, but you benefit, certainly in the startup case, by moving towards a kind of a product or a useful thing as soon as possible. So I suppose from a best practice, again, I don't know what best practice is, but practices I'm familiar with include everyone having some engagement with ML and being able to bring their own idea of the data, what it might mean, et cetera, and the business outcome. And also everyone, well, everyone is on call if there was a production environment, which there isn't yet, but there will be soon.
That I think what at least I'm getting is it's just dependent on the type of, is it an experiment versus is this the thing the business is dependent on? It's dependent on the organization itself, the size, what stage it's in. And so it feels like there's a phase where sometimes it's just important to get it out and test it. And then there's a phase where this is critical and we need to actually have better steps in place.
And there's a phase where there's like model development teams and different updates are happening at the same time. So then like, how does that team decide like, okay, with this combination or that combination, like what actually goes out? And so like a recommendation there might be like doing a meeting to discuss like what model launches are happening and just, has that been tested? Has that combination been tested? And can we go from there and try?
We talked a lot about like internal governance. And so this stuff can go sideways so many ways, either just by damaging your core business by not working well, or damaging customers in some way by having biased recommendations or broken recommendations. And and then there's legal risks for companies about the way they use data and stuff. And so like the idea that you would have like senior stakeholders in departments that have nothing to, they're like somebody who works in like finance and somebody who works in customer service and somebody who works in, the executive suite or whatever. Even if a small company, like you might have all these stakeholders who are like, I barely know how to spell ML. but I know if we get sued because of what you kids are doing, I'm going to be angry. So let's talk about that. Or I know if you make all of our customers angry and they go to our competitors, that won't work for my paycheck. And so, yeah, having like it does seem to be sort of a whole team, whole organization endeavor. Eventually, like you go from experiments to this stuff matters a lot pretty fast.
Yeah, I feel like this, and probably similar with, product launches or engineering launches, is that it's hard to have the one guidebook of this is what you should be doing in all cases, just because it's so dependent on so many things. Got it. Okay. Well, it probably bleeds into this next theme of questions I want to ask you all about, which is, so reliability depends on the stage of the organization that a company's at. How, I mean, the space is changing. I mean, on top of just companies growing and products and models and use cases changing regularly, this space, I mean, you guys are all following GPT-4 and everything that's happening. I mean, it's growing so fast right now. It is moving so fast. How, I mean, I've been seeing, to be honest, Reddit posts of NLP teams at large companies saying, well, are we even relevant anymore? With, I'm nervous about what's going to happen with GPT-4 and those large language models coming out. How do organizations need to start thinking about this shift as they're using ML? I mean, the models are changing changing underneath them. Use cases are there's probably more use cases that are going to come out, especially with generative. We're all trying to wrap our heads around the changes, but what should organizations be thinking about as they're starting to shift towards not only using ML, but also how do they try to leverage stuff like GPT-4 in their organization?
Niall, why don't you give us this a start?
Yeah, for sure. Like Niall.
So I think I'd say a couple of things. The first one is the fact that the space is changing so rapidly gives you an obligation to track that, because otherwise it is quite literally all of us may be redundant, or all of us may not be so successful as a result of narrowly focusing on this thing. If anything, it's kind of an argument for more generalist style approaches to what you are doing, which I think is good both from the individual point of view and also from the company point of view. And I don't expect this trend to like particularly stop or anything. Like, seems clear it's going to keep going for a while. The one thing I would say from a business point of view is that there may be kind of concentrating style effects where some of the LLM things only really work when you can train over billions of documents, yada, yada, yada. And so the question of how companies can best benefit from adopting this is the question of how to adopt the best API for this, rather than how to do those techniques yourself, which could be argued is like maybe good or maybe bad, but it is probably going to be a feature of the next couple of years.
We also talk about, like, generically an organization model that, like, the primary question is, does your organization have a strategy around ML? Have they thought about, or is it just like a set of experiments over here? But have they thought about it from the top down? And like Todd and I were just speaking at a panel for, oh my gosh, what was the name of, it was like a big medical group. And they have like a C-suite person who's in charge of machine learning and analytics for the whole hospital system. And he had some really interesting examples where the model builders had to go and like sit at the nursing station and figure out like how could they better occupy seats for people getting infusions. And they nurses were kind of doing this like intuitively. And so how do they build models for that? So they really kept like the model builders like really close with the business so they could solve real problems. And so like, as you're thinking about like, what what is your overall strategy? And they had a really good strategy of like, use ML to make their business better for their patients and for their staff and, you know, for the doctors and everyone. And so that was their strategy. And then based on that, then they started to do things. And so then you can think about like, you know, okay, this is our strategy. This is how we are organized. You know, we were talking about centralized, decentralized, but then based on that, we can introduce new processes. And so this is like a very generic model, but you know, it's kind of useful to use it to analyze, like, where are we today? What are we actually doing? How do we involve all these people in all these meetings? And how do we make sure and like rewarding people to, you know, actually do that work? And so how do you reward your product managers to talk about what they want with the model builders and et cetera?
And I think like, the only other thing I'd add to that is, I think everyone needs to take a deep breath for a hot second here, because like I want to cite Amara's law, which is people massively underestimate, like they overestimate change in the short run and underestimate it in the long run. And so the idea, so one of the things that happened when ChatGPT released their experiment to the public is the very next week, there were stories about how all lawyers and teachers were now unemployable. That's some of the stupidest crap I've ever seen. It's ridiculous. It doesn't make any sense at all, right? Because you're like, who's going to have a large language model write their contract that they depend upon without having a real lawyer review it anyway, who can talk to you about, right? No one's going to do that right away. But 25 years from now, people will definitely do stuff like that. And somewhere between here and there, a lot of things change, but nobody's out of work next week, but there's an opportunity. And so I think like if we take a step back and we stop freaking out about how everything's changing all at once, we can start to answer questions like what Cathy and Niall pointed out, which is like, what did you want to do? What was like, okay, so like if somebody invents a tool that like, you know, does everything, you're like, cool, it does everything. What do you want it to do? What's useful for your organization? And once you start to answer some of those questions, that's when I think things get easier and better.
Got it. And I agree. There's like, it can now pass a Google interview, so we don't need Google engineers anymore. And we are so far away from that world. But I think it's important that, you know, part of what I really loved, I think about the book that you all wrote is that it felt like it wasn't specific to the world of ML that we're in today. It's kind of talking about the processes and the way to, how does this, you know, there's recommendations based off of kind of what we've seen in the world of today, but it's also, how do we start building teams to be reliable as well, and building organizations to see success in ML. And I think a lot of that applies in the LLM world too. What advice do you have for individuals in terms of job market skills, what is there a specific role that they should be, in the past there, there's like 10 hottest jobs always had data scientists in them. And now people have things like prompt engineer is going to be a new job title, and, all these things. What do you all, any advice for individuals? How do they stay, relevant in the world of reliable machine learning?
I mean, I can start this. I was on a panel at NYU's Tandon School of Engineering last week with like 350 undergraduate, graduate students, many of whom were about to graduate into the worst tech employment market in many years. And a number of them were foreign students who needed US jobs to sort their visas out, right? So stakes are high for everyone, but for some people, stakes were very high. And they are freaking out. And I understand why they're freaking out. The message that most of us on the panel were giving was something Niall just said, which is fundamentals really matter here, because as things change, like you do need people who know basic math skills and good software skills and good like communication skills and collaboration. Like these things turn out to matter. That is not helpful to someone who's like, but how do I get the job? The one thing that I do think came out of that, there was a really interesting chemical engineer on this panel. And his point was like, all this tech stuff is going to go multi-industry. So right now we have a few narrow industries: retail online, advertising online, a few things here and there. We call that tech, but that's really just like advertising, cloud infrastructure services, retail, as we, enterprise software. But the chemical industry is going to need a bunch of machine learning and a bunch of data scientists, and so will real estate. And so like, as those things happen, maybe like the outrageously overpaid high tech jobs aren't as prevalent as they used to be. No, don't tell our employers that. But maybe the rest of the industries hire all of these people to do really interesting things. Like he was pointing out that like the carbon cost of chemical processes is 5 times the carbon cost of data centers globally. And we need to electrify that. We need to decarbonize that. And that's some real data science and some real engineering, and it's going to take some practice. And I was like, oh, okay, that's a big opportunity. We should probably figure that out. So sorry, Niall, you might have thoughts as well as you think about this, but that was the thought I had.
I think those are great thoughts. I think I'd say 2 things. First of all, the answer to this depends on your level of tenure, or like how junior you are, essentially. I think that, strangely enough, sometimes when companies are engaged in layoffs, they tend to lay off quite high tenure people in some circumstances. And actually that creates room at the bottom for low tenure folks. And low tenure folks are obviously not freed of the obligation to understand the fundamentals, et cetera, but they've a lot more freedom about what they can end up specializing in or even generalizing in, right? So the idea where you might learn your trade in somewhere other than a big tech company, which is kind of verboten for some time, but learn your trade and apply that in other places as well. Actually, that's a bit more feasible these days. And I think that the overall statement that way more people talk about ML than actually know about ML is true. And maybe if we increase the number of people who know about ML, like that will be a societal boon in some sense.
I think the other thing Todd was the founding manager for machine learning SRE at Google. And like, we told people, you don't have to know machine learning in order to come into the reliability team for machine learning, because you're still going to be working with systems. You're still going to be working with, when do you deploy something and how well do you do it? And how do you canary something in the real world? And so knowing some about machine learning is useful. But like, I think when we hired straight up, like out of college machine learning people, they were like, what am I doing? Like they had to learn all the operations pieces when they got on the job. The other piece that we talk about is like what mindset somebody has when they're working in machine learning. And we did a Slido poll at something that we talked at a little while ago. And the biggest ones were able to collaborate, understanding problems and really kind of going after a problem, and like being really open-minded, curious, good communicator. So I think all of these things, when you're working in a world that is changing really often, you have all your engineering background, but you have to also work well with people. So that would be what I would recommend.
Awesome. Well, I just wanted to say, now I know you have to hop off a bit early, but any last minute thoughts for you? Or if not, thank you so much for being a part of this.
Test in production. That's my last minute thought. Gotta run.
Bye, Niall.
Awesome. Well, Cathy, Todd, I have one last question for you all, and then this has been an amazing panel. I think there's so much more that's going to be, the last 6 or so months in the AI field has been insanely moving fast. If there's anything you had to adjust or go back in the book and say, well, is that still relevant in the world of generative and LLM? Or, there's something that you feel like you might dig in a little bit deeper in this world, what would that be?
You go first, Cathy. I'm thinking.
Tough question for you all.
That's a good question. I mean, I think this world of ML ops is changing a lot. And as we, I know our teams have been like,
Sorry, I want to say people are now, there's a new word called LLMops, or some people are calling it foundation ops, but there's new terms coming out, by the way, for
yeah.
this. So that, anyway, just wanted to say that's moving fast.
And I do think that it's a struggle, right? Because there are things that people didn't think about. There's ways that we've set up, when we talk about centralized infrastructure, there's ways that we set up serving infrastructure that needs to be adapted to be able to work in this way. And so I think that the overall question about adaptability and scalability is, when we talk about SRE, a lot of times we talk about how is that going to scale? And so I think that question still, it's still very relevant, even into areas that we can't even think about yet, right? And so this is part of, the LLMs have been not necessarily a glimmer in like a very specialized model builder's eyes for a while, but for the infrastructure part of things that I think people were relatively surprised. So it's going to be challenging. And as you said, things are changing really quickly. So
No, you're right. We had whole teams designed for model deployment and model serving. What does that world look like if you're calling an API to a third-party system, or even if you end up training and fine-tuning some LLM internally, does everyone in the organization call it? So yeah, that could totally change up centralized ML teams.
I think one of the legitimate, and we think that I agree with criticisms of the book, is that it's a little bit abstract, right? We don't actually answer the question like, well, what does your serving system look like? Do you have model server with a model sharded among it? What is the request router? So we're like, no, because, and this is like any tech book, the more specific you are, the shorter the shelf life of that book is, because things change. On the other hand, there's a lot of general stuff. The thing that is generally in there that I think we don't do as thorough a job of as I would now is thinking about the societal consequences of the power imbalance between large organizations and small organizations. So, so we don't talk about how do you get 80% of the value of a 300 billion parameter model in a 1 billion parameter model. Can you do that? What would that look like? Because a lot of people can train half a billion or a billion parameters, but very few people can train 300 billion or a trillion parameter models. Like, I work for a company that does, but there's not 5 other companies that can. There's not 10 other companies that can. And it's expensive. And it's a lot of energy. It's a lot of time. It's a lot of humans. And so like when we go back to the early days of databases, like databases used to be used exclusively by large corporations to get advantage against individuals. Like the grocery store kept track of all of your data and made sure to try to extract as much money from you as it could. And as an individual, you couldn't use databases to do anything. Governments didn't use databases to do anything on behalf of their citizens. We saw that shift over 20 or 30 years where now like structured data and data retrieval, it's just a thing we have. I want to like, as an employee of a large tech company, like I want them to do well, but as a citizen, like I want these technologies to be broadly available and accessible and democratically controlled. And right now, just the scale of them makes that challenging. So in the same way we address sort of ethics and privacy in a chapter in the book, a really good chapter, written by a contributor, I think I'd like to address scale and democracy challenges here as well.
Yeah. Got it. Super, I think it's super interesting. I also think you're totally right. Part of the reason I actually I think your book, the book kind of resonated is that it wasn't specific about XYZ. It really was, how do we think about in the long run, how does it become reliable? What are some practices we've seen organizations doing to adapt and change? And that's a great note to leave it on, Todd. So appreciate that. Well, thank you both and Niall for being on the panel. I think what we'll do is, maybe in the chat, for audience who are listening, if anyone has any questions about the awesome book that was written, please feel free to ask any questions. The authors will be available to jump in, answer them, and like have a discussion. And any last thoughts before we conclude, Cathy or Todd?
Thanks so much for having us.
Awesome.
I mean, the only last thought I have is you keep referring to the book we wrote, but did you have anything to do with any part of that at all, Aparna? Any piece of the book that maybe you contributed something to as well?
Yes. Well, thank you all for the opportunity. So I did co-write the monitoring chapter of that book. And I want to say it was an extreme privilege to be able to work with you all and collaborate on bringing something like that out to the world. So thank you for the opportunity, and let's go make machine learning reliable, y'all.
Thanks so
Awesome.
much.
Thanks for being on.
Thanks.